Hello Pre-Calc BC. Today we are moving on to day 5 and we're actually skipping a section. We're going straight to 2.5, Library of Functions and Parent Functions. And this is going to be a lesson primarily on piecewise functions, both graphing them, writing the equation of one from a graph, but then also writing the equation of a piecewise function based on a situation, which will be something new for you for this year. All right, so the first thing we need to talk about are our library of parent functions, and most of these should look very familiar to us. We have a constant function, which is just going to be the equation of f of x equals b, and b is really representing our y-intercept, right? The just value of the y-coordinate there. This is, just a horizontal line. We also have a linear function, which would be in the form f of x or y equals mx plus b, where m is our slope and b is still our y-intercept. Now you have the identity, which is also linear, but this is specifically the line y equals x. So it does have a slope of just 1. Quadratic, our parent function is just y equals x squared. This is one that should be familiar to us. Square root function, y or f of x equals square root of x, whichever you prefer to use. Cubic, y equals x cubed. Cube root, y equals cube root of x, and you should recognize the shapes of these graphs. Absolute value looks like this. And then finally, I mentioned this in another lesson, the reciprocal function. The reciprocal function is y equals 1 over x. And this is one of the examples of a function that is an odd function that does not pass through the origin. It is symmetrical over the origin while not passing through the origin. Okay, so that's kind of a special case for that. So let's go ahead and we are going to graph one. So this piecewise function has actually 3 different types of functions in it. We have an absolute value graph, we have a linear, and then we have a constant graph as well. This one will represent just a horizontal line. So over here we have our domains for each section. Now, one thing that I have done in the past, and this is entirely up to you, but I like to use a highlighter or my pencil, and I like to just kind of draw in the little regions. So I have one from -10 to -2, and again, you do not feel like you have to do this. From -2 to 8, and 8 to 9, which I'm just not going to draw that. Okay, so each of your branches should appear in those individual sections and should not go past the individual section. This first piece is an absolute value graph, and this is something you need to be really careful with because people forget about the vertex. So I would identify the vertex of this absolute value graph first, and that would be a -4, comma -6. So you're changing the value inside with the x, and then the value outside, we stay the same. So that's one thing to find, and I'm going to plot that. Okay, and then another thing you can do is just take each of these numbers here, and we're going to plug it into the function, and that will give us our y-coordinates. So for example, -10 plus 4 is -6. But the absolute value of -6 is a +6, and then we're subtracting 6. So you're going to have a point at 0, -10. Excuse me, -10, 0. My mistake. I was like, that's not right. So that would be here. And notice I'm putting a closed dot because I have this equal to. Okay. And then I'm also going to plug in a -2. -2 plus 4 is 2. Absolute value of 2 is still 2. 2 minus 6 is -4. Okay, so -2, -4, and that's also going to be a closed dot because of the equal to. You also have a 1 out front, so that 1 is representing your slope, but it's a +1 going in the one direction and a -1 going in the other. So you can fill in those extra dots And then we'll just connect, hopefully a little straighter than what I just did. Okay, so that's your first one. Next one, if you want, you can go ahead and you can plug in these numbers again. I usually find that helpful. In this specific situation, if you'd like to instead say, hey, oh, your y-intercept is at -3 and go down here and then just do your slope of 1/2, that's totally fine. Just keep in mind that we're fortunate in this case because the y-axis appears in our what's the word I'm looking for? In our like location or that we're trying to plot this line, but maybe what if you were trying to plot the line over here? Well, then you can't plot your y-intercept. So it might be a good idea to just plug those numbers in anyways, but I'm going to go ahead and do this first since I already started. So I've got my 1/2. These are going to be open dots, and they're open because of my symbols here. Notice this 1 dot was already filled in, so when you put an open dot over a closed dot, it's still just closed. Okay, and let's just confirm algebraically. If I plug in a -2, 1/2 times -2 is -1, -3 is -4, and you can see, yes, that's where my dot was. And then what was that, an 8? 1/2 times 8 is 4, 4 minus 3 is 1. So 8, 1, which is where that point ended up. Okay, and then the last one, we are doing a constant line up at a y-coordinate of 1 between 8 and 9, and it will start off closed because of this equal to. So I'm going to close that guy in, and then at the 9 it's going to be open, and just itty bitty itty little line, just like that. Okay, so there is your graph. Now we have a graph, and we are going to write the equation of this function. This is also called writing the definition. Okay, I'm sorry, I'm just going to the right page here. So writing the definition of the function. Okay, make sure you have an f of x equals or a g of x, something. And then make sure that you have both the equation as well as the domain restriction. So I prefer to do the domain restriction first. So for example, this first part goes from a -9, right, to a, that looks like a -1. -9, it's going to be a less than because that's an open dot. X less than or equal to, and it's an equal to because it's a closed dot, and that's a -1. Okay, and then we're going from -1 to 3, and those should both be open dots. Okay, and then the last one is from 3, and it's to the right. Notice you have an arrow, so we're just going to say x is greater than or equal to 3 for that one. Okay, and now we just need to figure out the equations. So the first branch is an absolute value. It does have a vertex. That vertex needs to be a part of our equation. So your vertex, it looks like, is at -6, 2. Remember, when you write your absolute value, you're going to switch the x coordinate. So we should have an x plus 6 and then a plus 2. And then the other important thing is to check out your slope. So this is going up, what is that, up 5? Up 5, and I think it's up 5 and over 5. So up 5 and over 5 is a slope of 1, so you can put your 1 out front or you can just leave it. Okay, so that's your first one. This next one, it doesn't look like it has a nice y-intercept, so we should find the equation of the line using one of the points as well as the slope. So let's see, slope first, down 6 over 4. Okay, so 6 over 4, that means my slope is 3/2. Well, actually I lied, right? Actually it's a -3/2. It is going downhill. Okay, and then I'm going to pick a point. I'm just going to use this one right here. I believe that's -1, 3. And now I'm going to start my equation in point slope form because that's a form that we use a ton in pre-calc, and also it's how I teach my Algebra 1 kids. So I'll do y and then the opposite of my y coordinate, so -3. equals my slope, which is -3/2, and then x plus 1. So x opposite of your x coordinate. And then all we have to do is distribute this. And then add my 3 over. And 3/2 is 1.5, so it's -1.5 plus 3, which is positive 1.5. And then that will just go right up here. Okay. And then the last one, what you can do here, it's definitely linear again, is I would find your slope first. So that was what, up 4? 1, 2, 3, 4, 5, 6, up 4 over 6. So that's a slope of 2/3. And this one you actually get lucky, because if you go down 2 over 3, you can actually use that slope of 2/3 to find where the y-intercept would be. So it would just be 2/3 x minus 9. Now again, that minus 9 isn't actually graphed. It's not in the region that we care about. But that is the graph of the whole line, and we are just graphing it where x is greater than or equal to 3. Okay. Now, domain. I'm going to erase all this so that I can actually see what was originally there. So domain are possible x's. So let's just take a look at this. Our lowest is -9, right? And we just want to see, is there any value of x that we do not hit? And there is not. It continues going to the right forever. Notice you do have an open dot at -1, but it gets closed again up here. And same with at 3. So this is just going to be from -9 to infinity. And notice I am using parentheses because that -9 was an open dot. Okay, and then for range, so my lowest y is down here at -7. And let's see here. We do have this arrow that's continuing up. So even though it looks like we're stopping at 7, eventually this line is going to surpass that. There also is no location where we're not hitting a y-coordinate, because all of this is going to get hit by that over there. And then same here, you're hitting this lower part. And then you're filling in that gap right there. So this is just going to be a 7, whoops, but a bracket 7, right? To infinity as well. Okay, because again, this arrow is going up. So it's literally, I mean, it's literally going to hit all of that. Okay, all of your y's. All right. All right, guys, a little movie magic here. Number 3, we are now cutting because this video got way too long, so I just cut it out. This is after the fact, but I am going to display the answer to it, and this is something that we can go over during our virtual meetings if you would like to do it and you do not understand the answer. All right, thank you. Okay. All right. Last thing we're going to do is we are going to look at how to write a piecewise function definition from a situation. So in May 2003, Nicor Gas had the following rate schedule for natural gas usage. You have a monthly customer charge of $6.45, and then you have a distribution charge. So depending on how much you use, you're going to pay a certain amount. So for the first 20 therms, you're paying that amount. For the next 30 therms, that's hard to say, 30 therms, you're paying this amount. And then for anything over 50 therms, you're paying this amount. You are also paying a gas supply charge at this amount per therm. Okay, so first we're going to actually do some calculations. Find the total charge for using 40 therms in a month. Okay, well, every month you have a monthly customer service charge, so that's $6.45. Okay, plus, I'm just going to go right down the line. Your first 20 therms are this much money. So I have 0.2012 that I'm paying for 20 therms. How many therms did we pay for, or should we be paying for total? 40, right? So we paid for 20 of them. Now there's 20 more that we have to pay at this new rate. Okay, again, it's 20 more because there are 40 therms total. 20 therms got the first rate, and then the remaining 20 therms got this next rate. But wait, there's more. There's also the gas supply charge. And the gas supply charge is paid on your total number of therms. So this is going to be multiplied by 40. Okay, and now, just because this video is running a little long, I'm going to just tell you what this is. I'm going to type it into my calculator, and you can either take my word for it or you can check it later. But we are going to round money to the nearest hundredth instead of thousandth because it is money, right? So this should be a 4178. Okay, again, you can type that in later, just because this is getting a little long. All right, so now we're going to do this again for 202 therms. Start with your total charge, 645. Okay, first 20 therms, I'm paying 0.2012. Okay, next 30 therms. So I had paid for 20, now I'm paying for 30 more. That's at the rate of 0.1117. All right, so how many therms have I paid for at this point? I've paid for 50, right? How many more do I still have to pay for if I'm trying to get 202? Well, I've paid for 50, I need to pay for 202, so I have 152 therms remaining, right? All of those 152 therms are getting paid at this last new rate. And when you type this in, please be really careful with the placement of your decimals. Okay, and finally you have that gas supply charge, and that is going on all 202 therms. Okay, and again, I'm going to tell you how much this is just to save the time of typing this into my calculator, and that is $166.32. Okay, which when you pay for gas in the winter, oh boy, people, it's rough. It's not enjoyable. Okay. Finally, construct a function that gives the monthly charge C for X therms of gas. This is telling you to write your equation or your definition of a function. So make sure you have your C of X equals. And again, just like we did with writing the functions from the graph, I prefer to do my, my domain restriction first. Okay? So basically, this right here is representing your domain functions. You either can have between 0 and 20 therms. You can have between 20 and 50 therms, right? Because it says next 30. Or you can have more than 50 therms. That's representing your 3 different branches. Okay? We do need to make sure that we put a 0 is less than or equal to X less than or equal to 20. Because if you just say X is less than or equal to 20, and you don't put that 0, you're saying that you could have negative therms, which you cannot. So you do need to have like a 0 here. I also think you should have the less than or equal to instead of the less than, because maybe you aren't actually using gas, but you're still paying that customer service charge. So you're going to be paying for something. It's not like you just don't pay anything for the month. Okay. All right, so that's the first branch. The second branch, it says next 30 therms. So that would be 20 less than X. Okay, it does need to be a less than here because we're accounting for the 20 up here. And then the next 30, so less than or equal to, that would be 50. And then the final one is over 50. So that's just X is greater than 50. Okay, so now, when we write this function, I'm not going to make you simplify it. In fact, I prefer you do not because it will make my life easier. So we are just literally writing out how much each one would pay for, and I'm zooming out so I can actually see what I'm dealing with. So if you get between 0 and 20 therms, what do you have to pay? Well, you have to pay the 645, right? Plus, you're paying the 0.2012 times your number of therms. So your number of therms is X, right? Plus, you also have to pay your gas supply charge. So plus 0.7268 times the total number of therms, which is X. Now, I know that these are like terms and you can combine them. I get that, but it's going to get a lot more complicated in a minute. So just leave it, okay? You're going to learn something pre-calc. We usually don't simplify very much. All right, so next one. Now we're paying between 20 and 50 therms. Well, you still have that service charge, okay? And then you have the 0.2012, but it's no longer going to be times an X, okay? And that's because we are now up between 20 and 50 therms. So you already paid for 20 therms. This is now a 20, okay? Because this is now saying, like, I don't know, you pretend you did 48 therms. 0.2012 times the 20 therms originally. Okay, that's the same thing that we did up here. But now you have this new cost plus 0.117 times, oops, there's another number, 1117 there, times, and what people want to do is put X. But that is not correct because X is representing your total number of therms. Think about it. You already paid for some of your therms. How many did you pay for? You paid for 20 of them already, right? So the amount that you still need to pay for is X minus 20. All right? Because like if you, let's say this was 48 therms, you paid for 20 of them, you would be paying for 28 therms still. 48 minus 20 is 28. And again, 48 is just my imaginary number that I'm thinking of. Okay, but wait, there's more. We still have that, what was it, gas supply charge? So plus 0.7268, and that is times every therm, so times X. Okay, you still with me? You got one more. More than 50 therms. You have your customer service charge. Okay, your first 20 therms, you're paying 0.2012. So 0.2012 for 20 therms. Now, the next 30 therms, you are paying that 0.1117. For how many of them? For 30. We are now over 50 therms. Let's say we're dealing with 100. Okay, I'm just imagining it. So I have already paid for 50 therms here. When you pay this new fee, which was how much? 0.0374. It is not times X, because again, you already paid for 50 therms. You only need to pay for the leftover amount. So X is the total amount of therms, and we already paid for 50 of them. So you're just paying for the remainder of that. Okay, and then your delivery supply charge, whatever it is, and that is times everything. Do you see what I mean here? Like, you probably don't want to distribute and combine all that, do you? No, I don't think so. All right, so there you go. That is your beautiful writing a function for piecewise situations. And just let me know if you have any questions. All right, have a good day.